Focus, focus, focus. So all we're working on today is measurement of rotation. There are two ways to measure rotation. One that you guys have been seeing for the longest time in degrees, and one that you probably haven't seen is radians. They're both the same. It's just kind of like feet and meters. It's just a different way to measure rotation. Cool or not cool? Cool. So let's see what it says here. Standard position of an angle and standard position in the Cartesian coordinate system if, by the way, Cartesian coordinate system just means x, y. You've been doing it all your life. Its vertex is at the origin, and its initial side is along the positive horizontal axis. So that means this. This is my reference. So that's 0 degrees. And if I go like this, well, I know that the x and y axes are perpendicular to each other, so then I know that's 90 degrees. If I keep going, that's 180 degrees from your reference. This is 270 degrees, and then once you do one revolution, that is how many degrees? 360. There it is. See, you guys already know that. One revolution is 360. The reference is your positive x-axis. Cool or not cool? Simple. Okay. Let's see. It is measured counterclockwise from the positive horizontal axis. That's what we just did. If the angle measure is positive, and clockwise from the positive horizontal axis if the angle measure is negative. Okay, all that means is this. If I go clockwise, if I start at the horizontal axis, this is always going to be your reference. If I go clockwise, that is negative. And that's it. Cool or not cool?
Oh, is that why it says clockwise from the positive horizontal?
Simple, right, guys? Okay, so let's see. It says one revolution is how many radians? What is this radians? Okay, the radians comes from this. Circumference of a circle. Do you guys remember what circumference of a circle is from geometry? No? 2 pi r. So one revolution in radians is 2 pi radians. See? So that means 90 degrees is pi over 2 radians. 180 degrees is pi radians. 270 degrees is 3 pi over 2 radians. And then, of course, one revolution is 2 pi radians. Excuse me. Notice that for radians, I don't put a degree symbol in the upper right-hand corner like you do for degrees. See? The degrees always have a little degree symbol in the upper right-hand corner, a little circle. So that's how you differentiate between radians and degrees. If you see a pi, that's a perfect radian. If you see 3.14, well, that's obviously pi, right? But 3.14 is approximated because it's a decimal. 3.14, pi goes on forever. Are we okay so far with all that information? What's up? Because it's 3/4 of a revolution. So, okay, you see this gap right here? From here to here, that's pi over 2, right? So, if you do it 3 times, pi over 2 plus pi over 2 plus pi over 2, well, look, 1, 2, 3. 3 pi over 2. So that you're just adding pi over 2, pi over 2, pi over 2. 3/4 of a rotation. One rotation is 2 pi, so 2 pi times 3/4 would give you 3 pi over 2. All right, how do we feel? Okay, the conversion. What are we going to use for conversion? So, conversion. So we know that 360 degrees is 2 pi radians. And you could use 360 equals 2 pi, but we're going to be using this one because it's easier. Conversion. So if I want to go from radians to degrees, I take my radian and I multiply it by 180 degree over pi. And I'm going to change it to red. If I go from degrees to radians, I'm going to take my degree, and this is multiply, right? I'm going to take my degree, and I'm going to multiply it by pi over 180. Are we okay? Okay, so here it is, let me explain it one more time. Here it is in radians, 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and 1/4 revolution is 2 pi. And here it is in degrees. Not color-coded by any means. 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees, once I've done a whole revolution. The positive x-axis is your reference. This is your reference. This is your reference. Cool or not cool, guys? Nothing crazy, right? Okay, so let's start. And it says, this is a definition, or this is like a formula, but I don't want you guys to be a robot. So let's talk about it. Two angles in standard position are coterminal. We'll talk about what that means. If and only if the radian measure differs by a multiple of 2 pi if you're in radians, or 360 if you're in degrees. So put 360 and put if degrees. What does all this mean, Chop? I don't understand. What is, by the way, this is called phi, right? Phi. All right, phi equals theta plus minus 2 pi n, or n is any integer. N, did I say that in here? Oh yeah, I did. Where n is any integer. N is any integer. Okay, why this formula? What about in degrees? Okay, let's talk about it. Let's talk degrees first. So let's say I have 30 degrees. 30 degrees measured from your positive x-axis. So here's 30 degrees. So notice this ray. What ray, Chav? This ray. If I were to do a full revolution from here, so let's say, look, I'm starting at the positive x-axis. See that one in sky blue? That one is, let's see, what's 30 degrees plus 360? So 30 degrees and 390 degrees are coterminal. They create the same ray. Does that make sense? Because it creates the same ray. Sometimes they call that ray the terminal side because that's where it, quote unquote, terminates. That's where you stop. Nothing crazy, right? Perfect. So there it is. That's all they're talking about, guys. So 390, so I would say 390 degrees and 30 degrees are what? Coterminal. They create the same ray. Same thing with radians, and I know you guys are not super familiar with radians just yet, but if I had an angle like this, and I'm going to say this is pi over 6, which is the same thing as 30 degrees, don't worry, we'll talk about that. And if I do a full revolution and I get to there, that's the same thing as saying 2 pi plus pi over 6. Notice, look, the denominator is 6, so all I got to do is multiply by 6 over 6. So 6 times 2 is 12. See, 12 pi over 6 is still 2 pi. So pi over 6, and let's see, what is this one? Theta equals 12 plus 1, 13 pi over 6. And I know it's, there we go. So what am I going to say about this one right here? That theta equals pi over 6 and 13 pi over 6 are both coterminal. They create the same ray. How do we feel, guys? Do we feel okay? Okay. I'm kind of going a little bit fast, only because you guys are going to be in the cafeteria in a little bit, and I want to make sure that I cover everything so you can do the activity. Reference angle. Your reference angle, just right, it's always, always, always positive. Always acute, always positive. Always positive. Always. The reference angle of an angle in standard position is a positive acute angle between the horizontal axis and the terminal side. So that means the reference is always with the x-axis. So, Chop, what does that mean? That means if I have an angle like this, this is your theta r. I mean, this is your theta. This is your angle, the measurement of your angle. And this right here that I have in sky blue, that is your reference. And don't worry, we're going to practice.
So what does your reference do? Like, why is it important?
Oh, because when you get to physics, you're going to be always doing your forces with respect to the normal, and the normal is always your horizontal, and you're going to be doing it with component-wise, your x and y component, and you need that reference angle to figure out what you're going to do, like cosine 30 degrees or cosine, you know what I mean? Instead of writing cosine 120, you're going to write cosine 60, and you're going to break up your components. But right now, when we're doing this, you're kind of like, oh, what's the point? But you'll see as we get more advanced. Good question, by the way. Gonzalez, do you remember using your reference angles in physics? Yeah, okay. All right, here we go. You guys ready? We're going to go slow, don't worry. And this is all well thought out. I know that you guys like degrees better, so I put degrees here. It says sketch angle 71, 133, 254, and 317 in standard position. That just means I want to see where it's at. and calculate the measure of each reference. Okay, 71 degrees, what quadrant? And let me draw the quadrants just in case we don't know it. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. And why do they use Roman numerals? I'm not exactly sure, guys. I'm not a history buff. Maybe you guys can do the history buff and figure out why. But I've never seen any textbook write it numerically. 1, 2, 3, 4. It's always in Roman numerals. Okay, you guys ready? In what quadrant is 71 degrees in? 1, 2, 3, or 4? 1. Exaggerate quadrant 1. Here's my ray. That's my, it doesn't really matter. I don't care how close it is. You should be closer to the y-axis than the x-axis, but it's not a big deal. I'm not going to be measuring it with a protractor. There it is. I'm in quadrant 1. Because you're in quadrant 1, and because 71 degrees is already acute, what is my reference angle? Is it also the same thing? Yeah. In quadrant 1, that's the property it has. Whatever angle it is, if you're in quadrant 1, that's automatically your reference. What's up, Houston? If it's in quadrant 1, yes. Yes. Unless you're in quadrant 4 and you go negative and then you just take the absolute value of it. Because in quadrant 1, it's already acute. It's already below 90 degrees and it's already respect to the horizontal. All right, 133 degrees. What quadrant? 2. So I'm going to exaggerate quadrant 2. I'm going to change colors. Let's see. Let me do sky blue. So here it is. I'm trying to color code it. Why is it doing that? I don't know. Maybe my laptop. I am going to bring my laptop as soon as I download some software. Here we go. So, boom. Exaggerate quadrant 2. 133 degrees. It doesn't have to be perfect. You start from the positive x-axis. Theta equals 133 degrees. The reference angle is respect to the horizontal. So this is my reference angle. Theta r. How do I find it? Subtract it from what? You're right. You subtract it. Subtract it from what? 180. Good job. Why do you say 180? Yeah, whatever the theta, 133 plus theta r equals 180. Good job, miss. You must have had a really good math teacher. So what is 180 minus 133? So that is, there it is, 47 degrees. That's my reference. Your reference angle will always be acute. Are we okay? I'm going to go to burnt orange for you Longhorn fans. 254 degrees. What quadrant? 3rd. So I'm going to exaggerate quadrant 3. It doesn't have to be perfect as long as it's in quadrant 3. Theta equals 254. 254. The reference angle is always with respect to the horizontal. There's my reference angle right there. How am I going to calculate it? Not from 360. From 180. So I'm going to do, but this time I do 254. Do you guys notice that? 254 minus 180. Because if you do 180 minus 254, you're going to get a negative angle. So 254 minus 180, what's that? 54, 64, 74. Is it 74 degrees? Let me know. I always make mistakes. So my theta r is 74 degrees for that one. Because it's your reference angle. Your reference angle, by definition, is always positive. Yeah, see, it's right, underline right here. Positive acute angle. You can always have a negative angle, but for a reference, it needs to be a positive all the time. All right, 317 degrees. What quadrant? 4. So here it is, quadrant 4. I'm going to exaggerate quadrant 4. That theta is 317 degrees. Look how close you are to doing a whole revolution. So how do I find my theta r? From what? 360 minus 317. What do we get? 27, 37, 47, 57, 43. 43 degrees. Theta r equals 43 degrees. It just depends where you are at and what quadrant. If I'm in quadrant 1, leave it alone. If you're in quadrant 2, you're going to go 180 minus whatever your angle is. If you're in quadrant 3, it's your angle minus 180. If you're in quadrant 4, 360 minus your angle. What's up? You're never going to use the 90 or 270 because it's not with respect to the vertical. It's with respect to the horizontal axis. Good question. Always with respect to the horizontal. But why? Because in life, you always, anytime you're doing a physics problem, you're always going to reference your horizontal. I'm sure there are situations where you're going to reference your vertical, but it's always easier to reference your from your line of sight, your horizontal. Does that make sense, guys? Okay. All right. Find an angle in each quadrant. So this is what you're going to be doing in your delta, but I recommend you don't do the delta until homework. And don't worry, relax. I made sure I don't believe in doing homework for hours and hours on end. If you're wondering, like, man, how long is this delta going to take me? According to Delta, it gives me a little estimator. It said 24 minutes. Now, if you're fast, you'll probably do it in 15. If you're slow, it'll probably take double if you're slow. Come in. If you're having a hard time, come in. I didn't put the due date until Wednesday at 4 p.m., so we'll even have class even then. You know what I mean? So if you're having a hard time, just come in, guys. All right, here we go. Find an angle in each quadrant with a common reference angle with 204 degrees. So first, where's 204 degrees? Quadrant 1, 2, or 3? Or 4? I don't know. Not quadrant. Quadrant 3. So I exaggerate quadrant 3. And I'm going to go, let me see, let me go to red. There it is. Sorry about the sound effects. You don't have to do the sound effects. 204 degrees. What is that reference angle? That's my reference angle right there. So I'm going to go theta r equals, let's see, how do I calculate it? 204 minus what? 180, and that's going to give me 24 degrees. So that's my, there it is. Okay. We haven't answered the question yet. Look what it says. Find an angle in each quadrant with a common reference angle with 204 from 0 to 360. So my reference angle is 24 degrees, right? Here is quadrant 1. In quadrant 1, 24 degrees. Theta equals 24 degrees. Well, I guess I should write theta r first. Theta r equals 24 degrees. And so in quadrant 1, colon, my theta is just 24 degrees. In quadrant 2, so here it is. I'm going to draw quadrant 2. Again, 24 degrees. Theta r equals 24. So I need to figure out what this is. That guy. Well, how do I figure that out? Yep, 180 minus 24. What is that? 180, 70, 60, 156. So there it is. In quadrant 2, your angle is 156. In quadrant 3, that was given. I'm going to put given. 204 degrees. 204 degrees. And in quadrant 4, let's see what that is. And let me change my color here. Quadrant 4. All right. So here it is in quadrant 4. There's my reference angle. Trav, you said when you count clockwise. Well, I'm not counting clockwise. I'm just saying that's my reference angle, right? So here we go. What is this distance? Well, you're 24 degrees from 360. Yep, 360 degrees minus 24. That's going to give me 36, 54, 336. Yep. So in quadrant 4, it is theta equals 336 degrees. I really should be saying theta, but that's fine. I didn't do it for number 3. And that's it. That's what you're going to be doing on Delta whenever you log in. And then just converting degrees to radians, radians to degrees. How do we feel? Okay. Let's go to the next one. Yes. Well, that one was given to me. That's the question they had. It says find an angle in each quadrant with a common reference angle with 204 degrees. So they're telling me, give me the reference angle when my angle is 204. So I went to 204. There's my 204. I know that I'm in quadrant 3 because 204 is between 180 and 270. And then I just took 204 and subtracted 180 to find my reference. Because I need this gap. Well, because the distance between the positive x-axis and the negative x-axis is 180. This distance right here that I'm writing in sky blue, that is 180 degrees, miss. And but I don't want that, right? I want to go all the way here. So I went 204 degrees, and I got to subtract 180 to get that little guy. Let me go to the board so you can see. The distance from here all the way to here, that's 180 degrees. And the distance from here all the way to this ray is 204 degrees. So to get this gap, I go 204 minus 180 to find out this gap. Right? Are you good or not? again.
Kind of lost. I don't know what I'm lost about. So, because all the other ones, like the reference point was behind after.
Oh, the reference point is always with respect to the x-axis. It doesn't matter if it's above or below. You just gotta take the difference from it.
And it couldn't be the other side because that would be like too big.
Well, the angle 204 must be in quadrant 3. It can't be in quadrant 2 because from here to here is 180. I'm above 180. 204 degrees is bigger than 180. You know what I mean? So I have to be there. And then to get the difference, I just did 204 minus 180. If I were to be in quadrant 3, I would have done 360 minus whatever angle I got. If I would have been in quadrant 1, leave it alone. If I would have been in quadrant 2, I would have done 180 minus whatever angle to get the reference. You know what I mean? Don't worry, we're gonna have more examples. We're gonna have more examples, Lizardi. Okay. Check out this one right here. And we're gonna talk to you guys about, do you guys have calculators in your desks? Okay, grab a calculator if you don't have one. Yeah, grab all those that are on the deck there. Yeah, just take it. All right. So example 3 says, sketch an angle, and I'm sorry that I have to do this all the time. It's just that I see the bottom. All right. Sketch an angle of 48.97 degrees in standard position and calculate the measure of the reference angle. All right. You guys ready? You can, if you wanted to, I've seen one kid do it, but don't. It's going to take you forever. You can, if you want, go, let's see, where am I at? 360, 720, and then keep going until you figure out where you're at. Oh, that looks like Saul. Okay. So here's the right, well, I don't know, I'm not saying it's the right way because there's many ways to do it. Here's what I would do. I would take the 48.97 degrees and I would divide by 360 because I know one revolution is 360. So you take your 48.97. Let me take my calculator. Oh, come on. Yeah, sorry, my calculator is slow today. Okay, 48.97, right? Divided by 360. All right, here's what I get. 13.602. Is that what you guys got? Okay, here's what that means. 13.602, ... It goes on forever. That 13.602, that 13 means it's done 13 revolutions. That 0.602777, oh, it actually goes on forever. 602, it actually goes on forever with the 7. 7777, that 8 is rounded. That 0.6027 is telling you 60.2777% of a revolution. That's what it means, guys. So start getting really good with numbers. Chav, I don't know what you're talking about. Okay, time out. When you're in physics or when you're in chemistry and someone tells you it takes 1.2 hours, what does that 0.2 hours mean? That 0.2 hours means 20% of an hour. So if you multiply 60 minutes times 0.2, the 20%, you're going to get 12. So 1.2 hours means 1 hour and 12 minutes. Does that make sense? Okay, Chav, why are you talking to us about 1.2 hours translating that to? It's the same. It's arithmetic, guys. That 0.602 is 60.27% of a revolution. So if I want to know how many degrees I'm at, you just take your calculator. And by the way, I want it perfect. So here's what I'm going to do. I'm going to subtract 13. Chav, why are you doing that? So now I have this number here, and I can go times 360. And then look, it's going to be a perfect 217. See? So I know that 360 degrees times 0.602777%, oh, actually, don't write the percent because I wrote the point right. That is 60%, 60.277%. That's going to give me 217 degrees. What quadrant is 217 degrees in? 3. Doesn't have to be perfect. There it is. Theta equals 217 degrees. What else do they want? Oh, the reference. All right, Lizardi. What is this angle right here? How would I calculate it? No pressure. This is a safe space. Heck yeah, Lizardi, look at you. So 217 minus 180. Let's see, what's that? 20, 30, 37 degrees. That's my reference angle. Theta R is 37 degrees. If you were, this is just a side note. If you were to have gone, let's see, if I would have just gone 0.602, look what happens, guys. 602,777. I'll even put 3 digits after it. If I were to do that times 360, look how it does not give me a perfect 217. I mean, you can pretty much guess it's going to be 217 with all those 9s there, but do you see what I'm talking about, guys? So make sure that you take advantage of the technology and use the memories calculator. Use the calculator's memory. All right. Relax. All we're doing is converting. See, it just says convert. And with this morning, I actually drew the references immediately. All right, so what did I put in the notes on page 1 if I want to go from radians to degrees? There you go. So I'm just going to go times 180 over pi. Pi's cancel out. I know that 3 goes into 18 6 times. So there's a 0 there. So that has to be 60 degrees. So pi over 3 is 60 degrees. Do you guys see how we did it? Look, we're going to do a whole bunch. 2 pi over 3. Well, look, guys, let's be smart. Let's be smart. Look, you don't even need to multiply by 180 over pi. Chop, what are you talking about? What are you talking about? I don't know. Pi over 3, you just told me is 60 degrees. So if I go pi over 3 plus pi over 3, isn't that 2 pi over 3? Well, so then that means I can just go 60 plus 60, right? And what's 60 plus 60? So look, you don't even have to do, like if you just use logic, you'll get it right every time. 2 pi over 3 times 180 over pi. The pi's cancel out, and I bet you if you did 2/3 of 180, that the calculator will tell you 120 degrees. Don't believe me? Here's my calculator. Let's see, 2/3 times 180. Look, check it out, guys. You're gonna get 120. OMG. See? You're not like brain. Oh, okay. It's all good. It's all good. No, it's all good. It's all good. Okay. You can, if you want, add pi over 3 plus pi over 3 plus pi over 3 plus pi over 3 4 times. And then just 60 plus 60 plus 60 plus 60. You can. It doesn't matter. So here we go. 4 pi over 3 times 180 over pi. The pi's cancel out. 4/3 of 180. I believe that's going to be 240 degrees. Cool or not cool? 5 pi over 3 times 180 over pi. You're going to get 300. 300. Sorry for saying it weird. Last one. 11 pi over 6 times 180 over pi. Pi's cancel out. Take your calculator. 11 6 times 180. So let's see. What is it? Times 180. 330. There it is. Yeah, don't double the... And we're done. How do we feel? Was this crazy? Nah, that wasn't crazy, guys. All right, this, I don't know if the SAT Level 1 Math Subject Exam is still offered. It was offered a few years ago, 5 years ago, but I think since the pandemic, maybe they stopped offering it. I'm not sure. You guys let me know. What if my rating does not have a pi in it? On the SAT Level 1 Math Subject Exam, there was a question that said, convert, well, not the exam itself, but a practice exam. So let's practice exam. Not that we actually, because we don't, right? Convert the angle 2.5 radians to degrees. Okay, you just take the 2.5 radians, and I'm going to multiply it. If I want to go radians to degrees, I just multiply it by 180 over pi. And you're going to get a decimal. So here it is. I'm going to go 2.5 times, and you can just type 180 over pi like this. You can use the fraction feature as well. 143.239. You can if you want, but because it's just one single 180 over... hold on. What's this? Oh, Sofia Ramirez. Okay. I'll answer it in a little bit. Okay, how do we feel? Okay. All right, we're good. Round to the nearest tenth. Oh, I didn't even 143.2 degrees. It's at nearest tenth, so that's the first digit after the decimal. Are we okay, guys? All right, here we go. Sketch angles. All right, relax. We're gonna go slow. We're gonna go slow. So first, let me circle this one first. Pi over 3. Look how slow I'm gonna go, guys. I'm going real slow. 0, pi over 2, pi, 3 pi over 2, and then 1 full revolution is 2 pi. Okay, I think it's easier to think of this like this. That pi over 3, think of it as 1/3 pi. So that 1 pi over 2, think of it as half a pi. And I think there you'll never get it wrong if you think like this. Okay, ready? Is 1/3 pi more than half a pi or less than half a pi? Less. So that means 1/3 pi is probably something like this. See? Theta equals pi over 3, or 1/3 pi. Do you see how we did it? And of course, you guys know from up here that pi over 3 is actually 60 degrees, but not a big deal. Okay, ready? We already know that 2 pi over 3 is 120 degrees, but let's try to do it with radians here. So I'm going to circle this one in red, and here we go. 0, pi over 2, maybe think of this as half pi, a whole pi, 3/2 of pi, and 2 pi. Is 2/3 of pi bigger than half a pi? But is it bigger than a whole pi? So I have to be in quadrant 2. Do you see how we're doing it, guys? So that better be 2 pi over 3. Oh, by the way, I need the reference angle. For the pi over 3, if you're in quadrant 1, the reference angle is itself because it's already a cube. I bet you're going to get this one right. Look at this. So my angle is 2 pi over 3. What is this difference for me to get to pi? I have 2/3 of a pi. I just need 1/3 of a pi. So that means this better be pi over 3. So your reference is pi over 3. See, you guys did it just by looking at logic. 2/3 plus 1/3 is a whole. No, trust your logic. We're all born with some type of intuition, some type of basic logic. That's why math is the easiest course, right? Math is the easiest class. No, guys, it really is. I mean, unless you start talking about abstract math. Now, those courses, I'll let the professors handle that one. When you get to, now I got an A, but I didn't know what I was doing. No, for reals. Like, I was a robot. Holomorphic functions, and I could manipulate formulas like crazy, but I had no idea what I was doing. And I told the professor this. He's like, "You got an A. How do you not know?" Like, I'm telling you, professor, I have no idea what you're doing. I just, whatever you do, I'm just doing whatever you're doing. And he didn't believe me, but I really didn't know what I was doing. So thank you for the A, but whatever. Okay, anyways, if you're seeing this, Dr. Fultz, I'm sorry. Okay, I don't think he's seeing it, but just in case. All right, here we go. Ready for the 4/3 pi? Is 4/3 bigger than a whole pi?
Yes.
But is it bigger than 1.5 of pi or 3/2 pi?
No.
Yeah, it's not. In case you're wondering, 4/3 is like 1 1/3, right? So let me write it here. 4/3, that is like 1 1/3. I didn't put the pi there. And then 3 over 2, that's like 1.5. So that's like saying 1.5 pi, and this is like saying 1 1/3 pi. Of course, don't write it like that because it's totally, it's never been written like that. Well, I'm not saying never, but whatever. All right, so I'm in quadrant. What quadrant am I in? Quadrant 3. I exaggerated. I'm saying it right here. So I'm going to say this is theta equals 4 pi over 3. So here's my reference. I'm how much more than pi? Yeah, this is pi right here. Yeah, I'm just another 1/3, guys. Look, a whole pi plus 1/3 of pi. Look, common denominator, I put a 3 over 3. 3 plus 1 is 4. Look at that, 4 pi over 3. OMG, everything just makes sense. Yeah, see, if you have little gaps with fractions or something, it's going to mess you up completely because of all your little gaps. But hopefully we're closing them right now. How do we feel? Okay, let's keep going. The last one, or 5 pi over 3. Let's see, 5 pi over 3. That's it's more than a half pi. It's more than 3 pi over 2, but it's less than 2 pi. So 5 pi over 3 is in quadrant 4. This is my 5 pi over 3 right there. So what is this gap to make it look? Well, look at that gap. That gap If I fill that gap in, I'll be a whole revolution. So I am, again, pi over 3, because 5 pi over 3 plus pi over 3 is 6 pi over 3. And 6 pi over 3 is 2 pi. Do you guys see that? Okay, perfect. Last one. 11 pi over 6. Look how close this one is to being 2 pi. 11 pi over 6. Bam. So that is 11 pi over 6. I put the pi first instead of the 11. 11 pi over 6. How close are you to a full revolution? Yeah, very close. What would make this fill up to 2 pi? 11 pi over 6 plus what? Plus 1 pi over 6. Do you guys see that? Because 11 pi over 6 plus 1 pi over 6 is 12 pi over 6. 12 divided by 6 is 2. Cool or not cool? Cool. So the reference angle on this one is 1 pi over 6. Good job, guys. Say it again. Change? What do you mean? It depends. Your reference angle depends on what angle you put. And it's never going to be larger. It better be acute. So it's between 0 and pi over 2. It cannot equal pi over 2 because then you have a right triangle. Okay. All right. Here we go, guys. We're converting these degrees to radians. How do I convert from degrees to radians? Look at your notes. Go to the first page. What does it say? Multiply by pi over 180. Chop, how do I do it in the calculator? Because pi goes on forever. Let me show you. Don't put the pi in the calculator. Just do this. Go 490. Let me clear this. 495. Leave the pi alone. Just divide it by 180. If you want, you can go 495 times 1 over 180. Doesn't matter. You're going to get a fraction. I should have turned it into a fraction immediately. You're going to get a number, 2.75. Push math. Turn it into a fraction. Number 1. Frac. Enter. Enter. Look at that. Put the pi next to in your numerator, 11 pi over 4. You can also say 11 fourths of pi, but 11 pi over 4 is usually the way you usually put the pi with the 11. But you can put 11 fourths and then times pi. That's the same thing as well. Are we okay? Okay. What do I do with the 720? Yep, by pi over 180. You might already recognize it. 720 is how many revolutions? It's 2 revolutions, no? Isn't 1 revolution 360? So 720 is 2 revolutions, but 1 revolution in radian is 2 pi. So 2 revolutions in radians is 4 pi. You can also do 720 divided by 180. You'll get 4. That's 2 revolutions, guys. Put in there. That's 2 revolutions. What's up?
So when you say 2 revolutions, it doesn't have to be a full 360, right?
No, a revolution is a 360. 360 plus 360 is 720.
Oh, okay.
Right?
Yeah.
Have you guys ever seen the X Games and ESPN? Those skateboards, I always wanted to be like a skateboarder. I was never good at it. Those people that do 2 revolutions, they call that 720. Oh, you guys don't watch that? Okay. Sorry. 60 degrees times pi over 180. Here we go. How many times does 6 go into 18? 3, but there's a 0 there, so that must be, actually, no, we're done. 6 pi over 3. Because I said 6 and 18. 60 and 18, 180 is the same thing. 60 goes into 183 times. Pi over 3, there it is. Cool or not cool? All right, 165 degrees times pi over 180. Take your calculator, go 165 over 180. So here it is, 165 over 180. And I can just go push math, and I can push frac immediately and get my fraction. 11 pi over 12. 11 pi over 12. I notice that the difference between 165 and 180 is the same as the difference between 195 and 180. Of course, one's positive, one's negative, right? So this one must be 13 pi over 12. But don't believe me? Let's see. 195 over 180. 195 over 180. Math, frac, enter. There it is. Put the pi in the numerator. Cool or not cool? Cool. 120 degrees. Multiply this by pi over 180. 12 over 18, I believe that's going to be 2/3. 2 pi over 3. How are we feeling, guys? Okay. Yes, I just didn't show it. Times pi over 180. I just looked at letter D because the difference between 180 and 165 is the same. That's 15 degrees. And the difference between 195 and 180 is also 15 degrees. So I said, oh, okay, I can just keep the 12. And 12 pi over 12 is pi. And just go another pi over 12 in front of it. All right, here we go, guys. Go to your activity 1. And because we're getting pretty close to crunch time, I'm going to do the radians ones first. Relax. Does everyone have activity 1? All right, look what it says. I prefer it today, but since you guys are going to go to the cafeteria, it's fine to turn it in to me tomorrow or the day of Wednesday. All right. Sketch an angle in standard position, mark the reference angle, and find its measure. So when I say find its measure, I'm talking about the measure angle. This is pi over 5, leave it alone. You'll see what I mean. Okay, here we go. Let's just do number 1. Exaggerate quadrant 1, chop y, because pi over 5 is not more than half a pi. And pi over 5 is probably something like this. So there it is. That's pi over 5, so that's its angle measure. And the reference angle, because I'm in quadrant 1, is also pi over 5. Are we okay so far? Okay. Go to the second one, or the number 3, because I'm going to do all the odd ones. This is 6 pi over 15. Is 6 pi over 15 more than half a pi? Oh, it is? Yeah, 6 over 12 would have been half. Since the denominator is a 15, this is less than half a pi, guys. Because you're in quadrant 1. You're already acute. If you're in quadrant 1, that's already the reference angle. That's 6 pi over 15. The reference is, again, 6 pi over 15. Are we okay? All right. Well, I guess, yeah, find its measure. We're finding the reference angle measure. Okay, look at number 5. 39 pi over 20. Look how close number 5 is to 2 pi. It's only pi over 20 away. If the numerator were 40 pi over 20, that would have been 2 pi. Does that make sense, guys? So you are probably really close to the x-axis like that. It doesn't have to be perfect, guys. I'm not looking for perfection. So your angle there is 39 pi over 20. And the reference angle, this little guy, theta r, pi over 20. Don't put degrees. These are radians. Is this making sense, guys? All right. Oh, no, child, what do I do? That's a negative angle. You're going to count clockwise. Exaggerate quadrant 4. 5 pi over 20. It doesn't have to be perfect. Theta, I'm going to put the little arrow here to indicate that I went clockwise. Theta equals negative 5 pi over 21. But your reference angle is never negative, so I say theta r equals, and I just take away the negative. 5 pi over 21. That's like quote-unquote first quadrant. You're not, but because you added clockwise, it's like quote-unquote first quadrant. Just take away the negative. Does that make sense, guys? Okay. This is probably the hardest one. So let me go ahead and do this one really slow. Check it out. I'm going to go real slow. 0, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Because it's going to negative. Do you guys see that? All right. I'm focusing on the 25 over 17. Take your calculator. So let's see. This is, I know it's more than a whole pi, quote unquote, but is it more than that 3/2 pi? Well, it's really close. If you're like super into numbers, then you can probably just look at it. So watch, look. I'm going to clear this. 3 over 2, you guys know is 1.5, right? Okay, let's see what this is. I'm just going to go 25 over 17. So I'm going to go 25 over 17. Look at that, 1.47. So that means I do not pass that 3/2 pi. Does that make sense? Remember, I got to go negative, so here it is. I'm going clockwise. But do I pass the 3/2 pi, the negative 3/2 pi? No, you get really close to it, but you don't pass it. So it looks something like that. There is my angle, negative 25 pi over 17. Now, what is this angle right here? You don't have to mess with negative angles. I'm going to slow down. you can just go, well, let's see. You can just go to the side and go 25 pi over 17 minus pi. Chav, how do I do that? Take your calculator and go 25 over 17 minus 1. Turn it into a fraction. Math, frac, enter. 8 pi over 17. It's never negative. Theta r equals 8 pi over 17. And sure enough, if you take that negative pi and you go negative pi and you add negative 8 pi over 17, you'll get negative 25 over 17. Uh-huh. And I just took away the negatives because I want it to be positive. How do we feel? Okay, we still got time. Let's see if we can do these in the back, guys. I'll do the 11 through probably 17 and then call it a day with you guys. Look at number 11. Negative 295 degrees. Chav, I don't know if I can do that. Yes, you can. 0 degrees, negative 90 degrees, negative 180 degrees, negative 270 degrees. You guys usually do pretty good with degrees. I think you guys are just more comfortable with it. Negative 295 degrees. What quadrant? The fourth, because you're going to do a whole revolution like that. No, it's a safe space. Safe space. There it is. Theta equals negative 295 degrees. Your reference angle with respect to the horizontal. So the number one mistake you guys do is you do it with respect to the vertical. So you're going to go 360 minus 295. What's that? 65. So that's your reference angle. Theta r equals 65 degrees. You see how we did it? Okay. 98 degrees. There used to be a band a long time ago. They were called 98 Degrees. It was a boy band. Where's the 98 degrees at? Second quadrant. Closer to the vertical axis. It's okay, miss. Closer to the vertical axis than the horizontal axis. But that's okay. Here's my reference. It's not 8 degrees. How do I find my reference? 180 minus 98. What is that? There you go. Do you see how we did it, guys? All right, last one. I'm going to skip number 15. I'm going to go right to number 17. 5481. What am I going to do with my calculator? So I'm going to go 5481. I'm going to divide it by 360. I'm going to push enter. And it tells me I do 15 revolutions and 0.225. So it ends at 0.225. So this one, you can just go 0.225. You don't have to add or subtract anything. And that means 22.5% of a revolution. I'm going to multiply that sucker by what? By 360. And there it is. I'm in quadrant 1. So this one, the 5481, I'm in quadrant 1. 81 degrees. And my reference angle is 81 degrees. I might want to show 5481 divided by 360, what was it, 15.225? And then I took that 0.225 and I multiplied it by 360, and that's how I got that 81 degrees. Cool or not cool? You think we can do this? All right, I'm going to let you guys go, do your thing. Well, I'm sure they'll call you guys down in a little bit, but see how much you can do. You can work together, and if you finish that, and if you have enough time and you have the energy, do the delta, and that's it, guys.